Hello everyone, so I'm starting a new project. It's called Go, and this is going to be a didactic multicolored research Go Weiqi Baduk playing program. The reason to create it, I want to make yet another didactic engine to make it easier for newcomers to enter the domain of computer Go programming. We are going to be using Go programming language. It's cool to have a program playing Go, written in language Go, isn't it? So the list of features this engine is going to have, so there would be a GTP interface. It's like UCI in chess, but in Go we have GTP. We would have obviously basic Go rules implementation. There would be lots of evaluations like evaluating ladders, life and death for a given group, etc. We'll have a territory counter, an influence estimator. All this is going to be driven by the multicolored research algorithm, and most interestingly, playouts would be based on handcrafted heuristics. And one day later, maybe I would add an integration with neural networks, but I don't promise that, so hence this maybe. We would be having lots of matches against other engines, and generally it would be experimenting. So without further ado, let's actually start writing some code. So let's get started with creating a new project. So this is the current working directory where the code lives. There will be a link in the description down below the video. So I say go module init and I call it go. And this would also be the executable name. Okay, so now it creates the file called go mod, and now I can use the text editor to create a file. I call it go.go. And here, this would be our package main, and I want to import the FMT module. In Go, I cannot import all the modules I would be using because it would give me an error like the module is not used. So at the moment I would only be using FMT, and generally we would be adding things to the structs, to the functions, to initialize those structs, because this is an ongoing project. I just have a bit of code being prepared, but no more. So we will be experimenting along the way. Okay, then we want to define a few constants. So we will define a constant for an empty square. This will be equal to 0. Also, black stones would be encoded as 1. Then white stones would be encoded as 2. Then we would need a marker to mark those stones we are counting when it comes to getting liberties of a group of stones. So this is a helper variable. Would be the value of 4. So we essentially will be using the 4th bit to bitwise or the board square content width, and then we could get back to the value by bitwise ending with 3, the contents of the board square. Okay, hopefully that makes sense. Then we'll have the offboard value, just let's make it 7, and also we will be marking liberties by the value of 8, again bitwise ending with the value with the 8th bit. So hopefully that makes sense. Okay, and now let's define the board struct. So type board. This would be the structure that would be containing the game state. For now, we just define the size would be the type of integer. So the board might be of different sizes like 9, 13, 19, or any other size. Okay, that's good for testing purposes if you want to see like how it goes on a smaller board. Then position is the array where it's the type, it's the slice of integers. That would be our one-dimensional array containing the board position essentially. Side to move, type integer, either white or black. And for now we'll define co, and that's it. So co is the square where you cannot put the stone. It's like an impassant square, sort of like in chess. It's totally different, but that's just the square where you cannot play the move if the square is co. Okay. So now let's create a main function. So function main I just want to make sure that we can compile and run. So let's say fmt print and go. Just saying go build, and it should create the executable called go. Let's have a look. Yeah, and it creates, and we have the output. Great. So going back, and now let's create a function to initialize the board. So we would be using the fancy Go programming language specific way to make methods or functions being connected to this given structure, sort of trying to mimic the object-oriented approach. Go doesn't have the classical object-oriented approach, but it can group methods to certain structures, and all those methods related to manipulating the board would be binded to the board structure. So here is the syntax. I say board pointer to board. We'll create the board object later. Is the name of init, and it would be, for now, let's just specify the only element. So this would be int. Size, type of integer. So we'll say board size equals to size plus 2, and we need to do plus 2 because of the off-board squares. That's very handy when it comes for capturing stones. So if we want to capture stones, we use off-board squares as if they were the stones of the color that is about to capture a group. So this is very useful. This saves lots of coding. If otherwise we don't use off-board squares, it's just quite hard to detect edges, especially in single-dimensional, especially in one-dimensional array. So hopefully this makes sense. Then we say board size equals to black. Okay. Then board.co equals to empty, and you might be wondering that this is the element within the board position, element 0, but since that is off board, stone would never be placed there, so having co equals to empty as at start is okay. And we have board position equals to, so since we don't know the size of the board up front, we want to dynamically allocate memory for it. So I can use the make function here. So this would be the slice of integers, and it would be the size of board.size multiplied by board.size. So if it's 9 by 9, it would be 9 plus 2 would be 11, 11 by 11. And that would be the size of the board, right? And once we have created the position, so we've allocated memory for it, it's already initialized with the zeros, but we also need to initialize off-board squares for the board. So let's go for it. I can say for row equals to 0 and row is less than board size and row plus plus, and same for column. So I can do substitute row by column globally. Okay, we define the square equals to row multiplied by board size plus column. And now if row is equal to 0 or row is equal to board size minus 1, so the first row or the last row, or column is equal to 0, the first column, or okay, it's a bit wrong here, column equals to board size minus 1. Okay, in this case we want to say board position indexed by the square is going to be equal to of board, essentially the value of 7. And otherwise, so else, although this is not needed because it's already zeros there, but just to make it explicit, we say board position indexed by the square is equal to empty. So the rest we do initialize with empty values. Okay, so now let's create a board. So I say board equals to new and new board, and now we can simply say board dot init, and after this I can do fmt dot print, and I want to print let's say side and board side and size and board size, and then co and board co, and finally position and board position. Okay, so let's try to run. Okay, undefined board. It's interesting. Yeah, obviously I'm forgetting about this column specific index. So this is the assigning of the value. Also, we need to provide the size. Let's make it 9 for now. Okay, and let's try again. Okay, so we have side. Okay, let's just make it a bit like this. So we have the side equals to black, size 11. That's because for a 9x9 board, the actual size is 11, co is equal to 0, and the board array has been initialized, assuming that the off-board squares would be equal to 7, which is the value for off-board. Okay, great. Now let's create a function to print the board, because printing the board this way is not very efficient. So I don't want to do this anymore, right? And instead, I just create another method here. So function, and again, board pointer to board, and we call it show, because in GTP interface there is a method called show board, so it's reasonable to name it this way. So we can essentially copy this kind of loop and just bring it here. The difference is that the square, but we don't quite need this, so I'm using the switch case here to distinguish between the contents of board position indexed by the square, and this might be either the empty square. So it's case empty, we just do fmt dot print, and we print just the period here. Okay, then we don't need to use break in Golang after the case statement, so it would be like would break automatically. So if we encounter a black stone, then we want to say fmt dot print, and conventionally X is used to represent black pieces, and case white fmt print, and O for white stones, right? And after, so in here we want to print the new line. So fmt print the new line, or we can just do print line like this. Okay. And yeah, we can probably try this already. So board.show. Okay, yeah, something went horribly wrong. So let's have a look. Oh, just the wrong place for this. So okay, now this is much better. But we also would like to add some row numbers and letters for columns. And letters for columns are a bit tricky, so there is no I is skipped. That's the conventional kind of thing. So let's add some logic for rows first. Okay, so before initializing the square, we can say, so if and row is greater than 0 and row is less than board.size minus 1, and also column is equal to 0. In this case, we want to add some indentation. So print and 1 like this. Then it might happen that if board size minus 1 minus row is less than 10, that we need to adjust our indentation. So here I can say fmt dot print and a space, and then we also want to say fmt dot print. Fmt stands for format, if I'm not mistaken, and here boards dot size minus 1 minus row. That's because we want to start from 19 and to 1 for 19 by 19 board. So we want to have the biggest number on top, and then by the time it goes down, it gets lower and lower. Okay, let's have a quick look if this is going to work. Okay, we have this from 9 to 1, which is great. And also want to make sure that with bigger board sizes, our indentations are not being messed. Okay, great. So it works for this, and also should work for 19 by 19. Great. So now we also want to add some letters naming columns. We escape this double for loop. We can do the following. I can do fmt.print, and I just want to compensate the indentation again. And then I do fmt.print, and here we want A, B, C, D, E, F, G, H. No I. We skip to J, K, L, M, N, O, P, Q, R, S, T. So that's the GTP standard, so we should follow it. Otherwise, the communication between our program and the GUI would be broken, because it would be essentially talking about different moves. So this is not going to work. Let's add a couple of new lines at the end, and let's have a look. Okay, A, B, C, D, E, F, G, H, J, K, L, M, N, O, P, Q, R, S, T. And now again, let's drop back to 13. Okay, that's because in order to avoid this, we need to properly slice. And to do this, we can simply do from element 0 to board size. I'm multiplying by 2 because I have spaces between letters, and minus 4. Okay, so let's have a look. Yeah, now this is great. Now if we do, say, 9 again. Okay, hold on a sec. Oh, this is 19. Okay, so let's do 9. Okay, ending up with J, A, B, C, D, E, F, G, H, J. Yeah, so this is 9 by 9. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, and 13. Okay, and 19. And yeah, we got it. So one last thing to add here is we want to know what the side is and what's the code. So I just do fmt.print and I guess 1, 2, 3. Hopefully that's enough. Maybe 4. Yeah, maybe 4. Side and so if board side is equal to black, I want to print just black and the new line, and otherwise I want to print white. Okay, and yeah, and finally fmt the print and 1, 2, 3, 4, 1, 2, cool. And for now we can just do board.co, but this would not be very readable. But anyway, let's go for it. Okay, we got the site and we got the co. Yeah, we also need to add the new line after. So maybe a couple of new lines. Yeah, this is good, but I want the square to be like in algebraic notation, like A19, like D4, Q16, etc. So the last thing we will do within this video is we'll create a function to convert a board index into a square in an algebraic notation, essentially returning a string. So let's go for this last task. So I want to create a function, and again this would be encapsulated within the board structure, so it would be related to board structure group to that. We'll call it get square, and it would be taking a square and integer parameters of the square index, and this would return the type of string. Okay, so we want to extract the column from the square. To do this, we do square divided by board size -1. Then to extract the row, we say square moduled by board size -1. Okay. Then we want to create a variable for our coordinate. So this would be equal to, so we want to make an array of bytes. Array of bytes would be turned into a string later, and 4 elements, essentially 4 bytes. And one last but not least thing to do, we want to compensate this translating of the number like A1, B2, 3, C3, Z is number 4, etc. into ASCII character. But since we have not HIJ but HJ, we need to compensate that. So we can say if column is greater than 8. In this case, we want to say coordinate indexed by 0. It's going to be equal to, we use an ASCII A as the integer value plus byte, convert into byte our column, and +1. All right, and otherwise, else character 0 would be equal to A plus converting the column to byte, and this is it, not adding anything. So we do compensate by adding 1. So age, and then if this is more than age, which is 9, which is 9, yeah, then starting from k, this will be +1 already. Okay, so this is quite simple. So this is quite simple, right? Okay, and finally, we want to say copy, and starting at the coordinate from the first element. Okay, so this is the matter of passing the row. We're using the str convert. We now need to import that as well. Integer to the alphanumeric character, and here we use board size and -2 minus row. Okay, -2 because of board squares. Okay, and finally we want to return stringify coordinate like this, and also we want to add str convert. Let's see if it still runs, if it still can follow undefined C. Oh yeah, it's not C, it's chord. Okay. Alright. Okay. We did not yet test this. So now here, instead of directly printing board co, we can say board get square and board.co. Now I would print some garbage, and this is okay. This means that there is no co, and we would leave it as is because it's not essential. We just remember that this means that the co square is not being set. Okay, so now let's set up the co manually equals to 100. I know that 100 is the square of Q16, so let's have a look. Yeah, now we have the square Q16 as our co, which is great. Let's do another test. So if this goes before the coordinate of h, so I know that the square 88 is the value of D16. So 88, and this should be D16 exactly, which is the case. Okay guys, this is it from my side. I think we've done quite a lot in this video, and some from the next one will probably create a count routine intended to find liberties of a given group on the Go board, and also keeping track of the squares that do formulate that group. So that's going to be quite exciting. That count routine will be reused many times along this program. So yeah, this is it from my side. Thanks for watching, and I'll see you in the next video. Until then, and cheers.